Question 8. Bond enthalpies are given in the table. These are the energy required to break those bonds. And the reactant are endothermic because you have to break this bond and break that bond to make a new bond. Making bond is exothermic and breaking bond is endothermic. So we need to find what is the enthalpy change in kilojoules per mole for the reaction below. For the reactant, I'm breaking 2 of H2S. 1 HS is that, so that's 1, 2, and times 2, that's 4. We've got 3 O double O bond, and we've got 1, 2, and times 2, that's 4 as O bond, and we've got 1, 2, times 2, so that's 4 OH bond. So to work out the energy values here, we need to do 4 times HS. So HS is 3, 4, 6. That's positive because it's endothermic. Plus 3 times O bond. That will be 4, 9, 8. That's endothermic because you're breaking that bond. And the exothermic bond will be 4 times SO. That's 5, 3, 1. That will be negative because we're making it. Plus negative 4 times OH bond. 4, 6, 4. And so if you multiply that together, we get this. And if you multiply that together, we get that. And these are positive values. Multiply those together, we get this one. And we multiply those together, we get that. These are negative values. So we want to compare the positive and the negative. Which one is bigger in size? That will be the one that dominates. Okay, so these are the reactants. So when we add the reactants together, we get 2874. It has to be positive because we're breaking those bonds. And on this side, we're making this bond, as you can see. So we would have the delta H to be minus 1102 kilojoules per mole, because we just take away that from that or add them together, and the difference is minus 1102 kilojoules per mole. The answer is B, so we just write B.